A very warm welcome to the class, children. So today's topic is study of sound part 3. In the previous video we had learned about the velocity of sound which has been affected in the gaseous medium, the audible infrasound and the ultrasound, the reflection of sound and the echo, and also the reverberation. In this video we'll be studying about the sonar, which also is based on the principle of reflection of sound. SONA, sonar. It is the short form of sound navigation and ranging. This particular technique is being used to determine the direction, the distance and the speed of any underwater objects with the help of the ultrasonic waves. How does this technique work? The ship would have a transmitter and the receiver. The transmitter would transmit or send the ultrasonic waves. In this case, they would hit the seabed and would get reflected back. So these reflected waves are then being received by the receiver. So then the distance can be measured at what level the ship is inside the sea. Similarly, this technique can also be used to determine if any obstacle is there when the ship is moving ahead. The transmitter would send the ultrasonic waves and the reflected wave. It would strike the obstacle and the reflected waves would come back and it would be received by the receiver. Then they are being converted into the electrical signals which are being then interpreted, that means read properly. Just we'll give a quick read. The transmitter produces and transmits the ultrasonic sound waves. These waves travel through water, strike the underwater objects and get reflected by them. The reflected waves are received by the receiver on the ship. Now the receiver converts this ultrasonic sound into electrical signals and these signals are properly interpreted. The time difference between the transmission and the reception is noted. That means how much time it is taking to reach that particular obstacle, that is the transmission time, and how much time it is taking, the reflected waves are coming back to the receiver has been noted. This time and the velocity of the sound in water gives the distance from the ship of the object which reflects the waves. So this is how you determine how much, at what depth is the ship inside the sea. So this was all about the sonar. Now where do they actually use this sonar? Sonar is used to determine the depth of the sea, as we studied. Sonar is also used to search underwater hills if there are, valleys, submarines, icebergs or any sunken ships. So anything which is there which kind of an obstacle it appears as. So this, if there is, obviously the sound waves would get reflected accordingly and we will come to know such things as the underwater hills, valleys, submarines or even icebergs. Okay. Another technique of this reflection of sound is being used and it is termed as sonography. This sonography technique also uses this ultrasonic waves which generates the images on the computer, or any which generate the images rather which we can see outside. So if I have to say that if you have any problem in the stomach, okay, you have some stomach infection, the doctor could not understand by looking from the external side. He has to examine from the internal organs. So in this case this sonography technique is being used. Now how does it work? It works as this is a probe. Okay, there is some gel which is being applied on the place where that particular organ has to be studied. So in this case the lady's stomach or the fetus, which fetus has to be examined. Fetus as in the lady is pregnant. So this probe is being applied with a gel. Then it appears as a transducer. Okay, it acts as a transducer. So they move this probe over the place which has to be examined. So this probe then sends the ultrasonic waves, then it gets dash to that or strikes the organ which has to be studied, and the reflected waves are being received by this probe, and that particular image appears on the screen. So this gel helps in a proper contact between the skin, okay, and so that the full capacity of the ultrasound can be utilized. So basically this sonography technique is useful in finding out any swelling is there or any infection or any pain is there inside the body. Also it helps in finding out the condition of the heart, the state of the heart, especially after an heart attack. Okay, so understood. So high frequency ultrasonic sound waves are being sent with the help of this probe. They are being striked onto the internal organ which has to be studied and again collected by the probe, and it appears, this image appears on the screen. And this method is very painless, so nowadays it has been increasingly used. Okay, so why this sonography technology is used, it is useful in finding the internal, in any internal problems of the body. Okay, this technique, as we say that technology rather, becomes a boon as well as a curse to the mankind. Rather, it depends upon us that how do we take it, because as I have mentioned that this sonography technique helps in studying the fetus or the child which is there in the mother's womb. It can also determine whether the unborn child is a boy or a girl. So the people try to take an disadvantage of it. If there is a girl, they try to kill it. So it is known as the female feticide rather is being killed, so that because they need a boy rather than a girl. So development in science have led to advances in technology which have helped us to make much progress. Basically, as I said, finding out an unborn child's uh, what condition, their health, is such a big progress to us that without even as I said, unborn child, that the child is not been born yet, but still we come to know it's all about its whereabouts, right? So it has been such a progress. But what the mankind tries to do, the human being rather, it tries to make a misuse of it. However, every coin has two sides, and the misuse of science has had serious consequences, that is, results for human life. The sonography technique can help to follow the growth and the well being of an unborn baby, but the increasing incidence of female feticide as a result of the discrimination between the girl and the boy child is an example of grave misuse of this technique. As I said, because the parents need the boy and not the girl, if they try to find out illegally, in India it is not at all allowed to find out the gender of the child. But there are certain, obviously certain doctors who still practice this. They find out they help the parents to, by taking money, they help the parents to find out the gender of the child, and then they kill the child in the womb itself. So female feticide is now cognizable offense. Cognizable means it is a serious offense, like a person literally doing a murder or a kidnapping. It is such a big serious offense under the PNDT Act. That is preconception and prenatal diagnostic technique. That means before only unborn child is being killed. So that is why it is a cognizable offense, as if it has been obviously it is a murder of a particular human being. Then, now we were talking about sound. We studied about the different types of sound. We studied the velocity of the sound. We studied about the reflection of the sound. How are we able to study or understand everything about the sound? It is because of this human ear. Okay, obviously ear is, because of this ear, it's an important organ of the human body. It helps us to understand the different sounds. It helps us to identify the different sounds. So we studied that there are the vibrations, there's the waves occurring. Okay, that is why the propagation of the sound occurs. In the similar way, the sound waves, when they fall on the eardrum, it also vibrates, and this is how the sound waves reaches our ears through the internal ears, and reaches the brain, which interprets the sound and tries to identify or distinguish between the different sounds. So this ear, our human ear, can be divided into three parts. It's outer ear, that is pinna, which can be seen, okay, the outside, which is out, protruding from your head, the middle ear and the inner ear. Now we have to study about this in just as briefly, rather I would say we have to study about them briefly. So this is the internal structure of the human ear. As we have known, the human ear has the outer ear or the pinna, the middle ear and the inner ear. So the function of the outer ear or the pinna is to collect the sound waves. As the shape of this pinna is somewhat, or it has a peculiar funnel like shape, it helps to collect the sound waves and pass through a tube. This tube is called as the auditory canal, and this is the pinna or the outer ear. So the sound wave reaches this auditory canal, and there in the middle ear you have the important part, which is the eardrum. What is the function of this eardrum? It is a thin membrane. Okay, it is a thin membrane. So what happens is, when the sound waves reaches the eardrum, as you all know, the sound waves have compression as well as rarefaction. They are made up of it. So when there is compression, when compression reaches the eardrum, the pressure outside it increases, and which pushes the eardrum inwards. Okay, then when there is rarefaction, the opposite happens. The pressure outside decreases and the eardrum is pulled outwards. So this pulling and pushing inwards and outwards of the eardrum results in the vibration of the membrane. Okay, this is the function of that eardrum. I would repeat, the eardrum is a thin membrane. The sound waves, when they reach the eardrum, they are made up of compression and rarefaction. So when there is compression, when the compression rather reaches the eardrum, the pressure outside it increases and the eardrum is pushed inwards. When there is rarefaction, then the pressure outside decreases and the eardrum is pulled outwards. So because of this continuous compression and rarefaction, there would be a vibration in the eardrum, and then this sound waves cause the vibrations of the membrane and they are being reached to the inner ear. Inside the inner ear you have something which is called as cochlea. The function, it appears like a snail. So this cochlea, the function of this cochlea is that it receives the vibrations from this eardrum and they convert it into electrical signals. They convert it into electrical signals which are then sent to the auditory nerve. They convert them into this cochlea, convert this vibration into electrical signals. These electrical signals are passed on to the auditory nerve, and from the auditory nerve they reach the brain, where brain analyzes these signals. Okay, understood? Very simple structure that we need to remember, that the outer ear, or that is the pinna, okay, outer ear or pinna, because of its funnel shape, peculiar funnel like shape, it receives all the sound waves. Then it passes through a canal, that is the auditory canal. Then it reaches the eardrum, which is a thin membrane. When the compression reaches the eardrum, the pressure outside increases and it pushes the eardrum inwards. When there is rarefaction, the pressure outside decreases and the eardrum is pulled outwards. Because of this continuous compression and rarefaction, there is a vibration of the membrane. This vibration then reaches the cochlea, which appears like a snail. This cochlea receives the vibration and converts them into electrical signals. These electrical signals and then are then sent to the auditory nerve. Through the auditory nerve they reach the brain, which analyzes these signals. As you can see, the internal structure is so delicate, you are not supposed to put anything inside, any sharp objects inside your ear, otherwise you would damage this eardrum. Even we are not supposed to hear the loud noises using your earphones. So with this we complete the chapter. So this is just a GIF which shows, see how this sound waves are coming and this eardrum is moving, the vibrations are occurring and then they are being transferred. Okay, so let's solve the numericals. The first one says the speed of sound in air at 0 degrees Celsius is 332 meter per second. If it increases at the rate of 0.6 meter per degree, what will be the temperature when the velocity has increased to 344 meter per second? Please note that the numericals D and E in after the end of the chapter in your textbook are omitted. Okay, D and E are omitted. We have to solve only A, B and C. Okay, so now they say that velocity of sound, okay, velocity of sound at 0 degrees Celsius, how much it is there? It is there 330 meter per second. If it increases at the rate of 0.6 meter per degree, that means at 1 degree Celsius, how much it would be? 332 plus 0.6 meter per second, correct? At 2 degrees Celsius, it would be 332 plus 0.6 plus 0.6, correct? So at every degree, that means at increase of every degree, 1 degree, okay, it is increasing 0.6 meter per second. So final stage at how much it has increased, they have given it as 344 meter per second. So what would be the total change in the velocity? Total change in the velocity would be the final, that is 344 meter per second minus 332 meter per second, okay, which is the initial 0 degree Celsius. So that comes up to 12 meter per second. So now we have to calculate what will be the temperature. So it would be total change in velocity upon rate of change. So total change in velocity, we just now found it is 12 meters per second, correct? And rate of change is how much? It is at every degree it is increasing 0.6 meter per second. So this and this gets cancelled. So it is 12 upon 0.6. Now when you have to get rid of the decimal, what we do? We multiply. Okay, we multiply by the number, either 10, 100. So how would we understand that? After the decimal, how many numbers are there? It is only one number. So you multiply it by 10. So similarly, when you are multiplying any number by the denominator by any number, you have to multiply it by the numerator as well. So you multiply 12 into 10. So that goes up as 12 into 10 is 120, and as we got rid of the decimal, it became 6. So 6 ones are 6, 6 20s are, so that is 20 degree Celsius. So at what temperature it would be 344 meter per second? It is at 20 degree Celsius. The next sum says Neeta heard the sound of lightning after 4 seconds of seeing it. So when she saw it after 4 seconds, okay, Neeta heard the sound. What was the distance of the lightning from her? The velocity of sound in air is 340 meter per second. So what is given? Given is time taken, that is t is 4 seconds. Speed of sound is 340 meter per second. You need to find out the distance. So velocity is equal to distance upon time, but we need to find out the distance. Therefore distance is equal to velocity into time. So your velocity is 340, your time is 4. So 340 into 4 gives us 1360 meters. So the distance of lightning is at a distance of uh, is rather I would write the distance of lightning from her or from Nita is 1360 meters. Okay. Next, Sunil is standing between two walls. The wall closest to him is at a distance of 660. This is actually 660 in my textbook. 660 meters. If he shouts, he hears the first echo after 4 seconds and another after another 2 seconds. What is the velocity of sound in air and what is the distance between the two walls? Now suppose he is Sunil. He is standing between the two walls. The closest distance if I take is yes, that is 660 meters. Okay, you need to find out first. We need to find out the velocity of sound in the air, and the next thing is we need to find out this is wall A. Suppose I take and this is wall B. So distance between these two walls. Okay. So when they say the wall closest to him is at a distance of 660 meters, if he shouts, he hears the first echo, that is after 4 seconds. So after coming back 4 seconds. So but while going it would be how much? 2 seconds. So 2 plus 2 gives us 4. Okay. But then another echo he is heard again after plus 2 seconds. So total how many? 6 seconds. Okay. 4 plus 2, 6 seconds. Understood? Don't worry. Once we are doing it, I'll more explain you all. So when he said okay something, the echo came after 4 seconds. So total 4 seconds, correct? So while going 2 seconds plus 2 seconds, that goes to 4 seconds. Understood this much? Then they said first echo was heard after 4 seconds and another after another 2 seconds. So 4 plus 2, 6 seconds total. Okay. So one distance we know, the other distance we need to find out, so that we can find out this distance plus this distance gives us a total distance. Okay. So solution, or we'll write first given distance of the closed wall, we'll take it as S1 is equal to 660 meters. Time of echo from closer wall would be is 4 seconds, but time t as I said that is total, no? So 4 upon 2 is equal to 2 seconds. So t1 is 2 seconds. Then time of echo from the distant wall, that as I said 4 plus 2, that is 6 seconds. Okay. So time t2 would be how much? 6 upon 2, that is 3 seconds. Okay. So t1 we have got as 2 seconds, t2 we have got as 3 seconds. Now we need to find out the velocity of sound in air, that is v, and we need to find out the distance between two walls, that is S1 plus S2. So first thing, solution, velocity is equal to distance upon time. So that V1, okay, V1 is equal to S1 upon T1. So V1 is equal to S1 is 660 upon T1 is 2. So that gives us to 330 meter per second. But also we know that V1 is equal to V2 because they are in the same air, no? It's not that once he spoke that one wall is somewhere in the water and the other wall is not. Both are in the same. So V1 is equal to V2. Okay, so that is equal to 330 meter per second. So V2 is equal to S2 upon T2, which is equal to that we need to find out, no, S2. So 330 is equal to, that is V2 we have substituted, S2 upon T2 is 3. Therefore S2 is equal to this 330 into 3, 330 into 3. Therefore S2 is equal to 990 meters. So we have found out your S1, we know it as 660 meters and S2 is 990 meters. So distance between two walls is equal to S1 plus S2, which is equal to 990 plus 660, that goes to 1650 meters. Okay.